today we're going to look at rationalizing the denominator of type 1. What we mean by type 1 is anything of the form a divided by the square root of b. So what's first of all the meaning of rationalizing the denominator? So it means that we don't want to have a surd in the denominator. We want to turn the surd into a whole number by multiplying both the numerator and denominator by the same thing. So let's take a look at an example. Let's say that we have 3 divided by the square root of 5 and we want to rationalize it. So I have the square root of 5 in the denominator and I want to get rid of that square root. How can I do that? Using the rules of multiplication of surds, if I multiply a surd by itself, I'm going to get under 1 square root 5 times 5, which I know is the square root of 25. When I do 5 times 5, 25. But 25 is a square number, and I know that the square root of 25 is equal to 5. So now I see that if I multiply a square root of a number by itself, I'm going to get a whole number. So let's go back in example 1, where we have 3 divided by square root of 5, and see how we can apply this logic. So I know now that if I multiply the denominator by square root of 5, I'm going to get 5 in the denominator. But in order to be mathematically correct, whenever we multiply either numerator or denominator in a fraction, we need to do exactly the same to the other one, so either numerator or denominator. So here in our case, we would also need to multiply the numerator by square root of 5. And we know that we are absolutely not changing the value of this fraction because this is just 1. And multiplying any fraction by 1 is not changing anything. So we're good to continue now. And we simply multiply now separately the numerators and the denominators. So what's 3 times square root of 5? We know this is just 3 square root 5. And in the denominator, I have the square root of 5 times the square root of 5, which remember, we've seen here that it's just 5. And this is it. We are now done with it because we know that we've rationalized it as in the denominator, we don't have a surd. Okay, let's take a look at another example. We have the square root of 2 divided by the square root of 3. So this is absolutely no problem now that in the numerator we have a surd. That's absolutely fine because you're going to see that the method that we figured out in example 1 would work here as well. So remember, in example 1, we had to multiply by the original denominator, both the numerator and denominator. So we do exactly the same here. We say, okay, the original denominator is a square root of 3. So I just need to multiply both numerator and denominator by the square root of 3. Once again, I'm not changing the value of the fraction as I'm just multiplying by 1. So what would be the square root of 2 times the square root of 3? Using the multiplication rules for surds, I just know that it's going to be the square root of 2 times 3. And then what's my denominator? Let's do it by steps. Again, I can write it under the same square root, so it would be 3 times 3. Then my numerator now is just the square root of 6. And my denominator is a square root of 9. But again, 9 is a square number, so this is just 3. So I know my answer would be the square root of 6 divided by 3. And again, I'm done because I can see that in the denominator, I have a whole number. It's no longer a surd. Okay, before we do some practice, let's do one more example. Let's say that we have 5 square root 2 divided by the square root of 5. So again, exactly the same strategy as before. We just multiply and divide by the original denominator, square root 5. So what we have here, remember we need to multiply the numerator and denominator. What we have here, we have 5 times, and now I need to multiply the square root of 2 times the square root of 5, which I can write under the same square root, which is just 2 times 5. And then in the denominator, the square root of 5 times the square root of 5. Remember, any third times itself gives us that number without the square root. So this would be 5 here. Now what I can see is that I can cancel these two 5s. And then my final answer would be just the square root of 2 times 5, which is the square root of 10. And now I've also have rationalized it, because in the denominator, remember that the square root of 10 is the same as square root of 10 over 1. So I still in the denominator have 1, which is a whole number, not a third. So we've also rationalized this one. And now it's also the time to say, please subscribe to the channel if you found this explanation helpful. And here is some practice. I'm going to share the answers in 5 seconds. So please stop the video now and try to do the questions on your own. So I hope that you attempted all questions and you were able to solve them all. So let's check them together. So the first one, we have the square root of 6 in the denominator. So we know that we need to multiply by square root of 6, both the numerator and denominator. So then we're left with, in the numerator, 7 square root 6. And in the denominator, remember, any square root number times itself is just a number that was under the square root at the beginning. So this would be the square root of 6 times square root of 6 is just equal to 6. Good, I hope you got that one correct. Well done. On to the next one. We have 9 divided by square root of 3. In the denominator, we have square root of 3. So we know we need to multiply both the numerator and denominator by the square root of 3. Now what we have is 9 square root 3 divided by square root of 3 times square root of 3 is just equal to 3. What we can see here is that we can simplify. We can divide 9 by 3, which would give me just 3. So my final answer would be 3 square root 3. Always make sure to simplify it as much as possible. So here we cannot simplify any further. It will be 3 square root 3. On to the third one. Here we have 7 times square root of 5 divided by the square root of 11. Again, we need to multiply by the square root of 11, both the numerator and denominator. So what would I have? 7. And then under the same square root, I multiply 5 times 11, which is just equal to 55. And in the denominator, I know the square root of 11 times square root of 11 gives me just 11. I hope that was also clear. And let's do the last one, which is one of the most interesting that we've seen so far. So we have 2 square root of 3 divided by square root of 12. Again, I need to multiply by the square root of 12, both numerator and denominator, in order to rationalize. So what would be this equal to? I have 2 times the square root of 3 times square root of 12. So write the 2 down, and now the square root of 3 times square root of 12 would give me the square root of 3 times 12, which is 36. And in the denominator, I have 12. But what is now this equal to? I can see that the square root of 36 is equal to just 6, because 36 is a square number, 6 squared is 36. So in the numerator, I have 2 times 6, and in the denominator, I have 12. Okay, we just do 2 times 6, which is 12, and then in the denominator, I have 12. But I know that 12 divided by 12 is just 1, so my final answer would be 1 here. And again, we see that we have rationalized the denominator of all these examples, because we see that we have a whole number in the denominator, or for examples 2 and 4, we don't even have the denominator, it's just 1. We have done all these. I hope you get them all correct, and I hope you find these explanations very helpful. Thank you so much for watching. Subscribe for more topics. Comment down below what topics you want to see next. Thank you.